So class question 9. By referring to figure 8.5, we are given you a graph of the variations of extension with the force F for a spring A. So we would like to calculate the strain energy of the spring that's stored when the force is extended by 6.4 Newton. So class, if you refer to the concept we learned in lectures, when a wire is stretched by a force F, the work is done on the wire and it will be stored within the wire in form of strain energy. And this strain energy can be calculated by using equations U equal to half multiplied force multiplied the elongations of the wire. Or we might also calculate the strain energy from the graph force against elongation or extension, whereby the strain energy will be equal to the area under the graph. So we are going to use this concept to solve questions 9. So we are going to use equations U equal to half force multiplied the extension or the elongation experienced by the wire. So I want to calculate the strain energy stored when it was extended with a force of 6.4 Newton. So I need to determine what is the extension of the wire when I apply a force of 6.4 Newton. So we can refer to the graph given. So when my force is 6.4, okay, 6.4 is here. So if we refer to the graph at force 6.4, when my force is 6.4 Newton, so I try to read the value of extension obtained. So the value of extension obtained will be 8 to the power of negative 2 meter. Okay, then I can substitute into the equation half. When the force applied is 6.4 Newton, the amount of extension will be 8 to the power of negative 2. Then class, you may pause the video to do your calculations. So if we calculate correctly, we should get the strain energy will be 0.256 joule. And then class, basically if you don't want to use the equations, you might also using the concept strain energy is the area under the force extension graph to solve these questions. So after you have identified what is the extensions obtained when our force is 6.4 Newton, you can calculate the area under the graph. Okay, so this area under the graph will equal to the area of a triangle. So I'm going to have 1/2. The height of the triangle will be 6.4 Newton and the base of the triangle will be 8 to the power of negative 2 meter. So 6.4 multiplied the base of the triangle is 8 to the power of negative 2. So you will also get the same answer, 0.256 joule. So basically you are going to have two ways in order to calculate the strain energy. You can use the equations or you can use the concept area under the force against elongation or the extension graph.